In this question, we are told that there are two towns and they are both on the equator. The equator is 0 degrees north. They are both on the equator and they are also both on the eastern part of the globe. So the first one is on 9 degrees east. 9 degrees east. That's 9 degrees east. And the second one is 32 degrees east. 32 degrees. So since they are both on the equator, the first one is here. We called it Gabon. So this is Gabon. And the other one is Uganda. So this is Uganda. And we are asked to find the distance apart along the equator. So looking for the distance apart along the equator, that means we are looking for this distance here. That's the distance we are looking for. And because it's along the equator, we will trace this point to the center of the equator. Center of the equator. So that it becomes the radius. This becomes the radius. I'm using capital R because this radius that you see here is the radius of the Earth. So, and this is the angle at the center. Let's call the angle at the center theta for now. So the first thing you want to do is to calculate theta, and we call that angular difference. So the theta, which is the angular difference, is the difference between these two numbers. Why? Because they are on the same side. If one of them is on the eastern part and the other one the western part, we are going to add the numbers together. But right now they are both on the same part of the globe. So we're going to subtract the numbers from themselves to get a positive difference. So we have this. And if you solve that, you're going to have 23 degrees. 23 degrees. So, and this is the distance between 2 points on a great circle. So the formula will be distance equals theta over 360 to pi r. Something about this topic is that you need to know the formula that goes with every kind of question. So distance between 2 points on the great circle, you use this formula and just simply substitute the values, and you have 23 over 360 times 2 times, let's check if they gave us radius, the pi. We are not given the pi, so let's just use 22 over 7 times radius of the Earth, which is 6400 kilometers. Then you solve, and after solving you have 2568 kilometers, which you could approximate to 2600 kilometers to two significant figure. And it's as simple as that. So all you need to know is the formula to use in this case. That's it. In this next example, we are told that there are two towns, in Egypt and Botswana, and they are both on the same longitude. The longitude is 25.9 degrees east. So you can see their latitude, 31.6 degrees north. So I place it towards the north, and the other one is 24.8 degrees south towards the south. These are their latitudes, but they are both on the same longitude, and longitude is also a great circle. So we're going to do exactly the same thing we did with the previous question that we solved. In the previous question, the 2 points were on the same great circle, and we traced to the center of the great circle, the equator, the center of the great circle. Now, and we use capital R. We're going to do exactly the same thing here. We trace this point and this point where the two towns are to the center of the globe, and that will be capital R and capital R, and the angle between them will be theta, and this is the distance we are looking for. Now, we need to get theta. Theta is the angular difference. This time around, we're going to be adding The other time we subtracted because they are both on the same side, east and east. But here, one of them is towards the north, the other one is towards the south. They're on different side of the pole, so we're going to be adding. So we add, we get 56.4. So we use exactly the same formula that we use. This is the formula for getting the distance between any 2 points on a great circle. So use it, substitute the value, and you solve. And that will be your answer to the two significant figures. I would like to say something before I solve the next question, and I want us to pay attention. Anytime you are asked to find the distance between any 2 points, say there is a point here A and there's another point here B. So this is my center. Go like this. This is the distance between the 2 points. This is also the distance between the 2 points. I could either go this way or go the other way. Now, this is the angle theta. You can also call this one theta or beta, whatever you want to call it. Now, anytime they ask us to find the distance between any 2 points, the angular difference must not exceed 180 degrees for it to be the shorter distance. So anytime you're calculating and you add up your angles and you discover that it's more than 180 degrees, you need to subtract from 360 so that the angle you get will still become the shorter distance. But if you get 180, that is the highest value you can have when you're dealing with shortest distance. When you're dealing with the shortest distance and you want the angular value, it must not exceed 180 degrees. Please take note of that because you will need it. So let's continue. Now looking at this question, the question says that there are 2 points on this equator, and those points are P and Q. We are told that they are on the equator, that's why I put 0 degree north there, and P is on 173 degree east. Let me draw something here. 173 degree east. If I call this my 0 and I start moving 90, 173 will be very close to 180 somewhere at the back. So I'm going to use broken line for that. So this is my 173 degree east. And the other one is 75 degree west, visible. From here 0, 75 somewhere here, visible to me. That's my 75 degree west. Now, they are both on the equator. This is at the back. I use broken lines, so this is the place I have my P. This one in front of me is the place I have my Q. So they are both on the equator. I'm tracing them to the center of the equator. I want the angular difference. Now I could go this way or go this way. I want to go this way. I call this my theta. It does not matter how you go. When you calculate your theta, you will know the difference. So this is the angle. This is the side I'm looking for. That's the distance I'm looking for. So that's my D. So you can see that. And this is my radius. Right now you should get used to it. That's my radius. So the first thing I want to do is to calculate my angular difference. My angular difference in this case, I want to say is 73, 173. They are on different poles plus 75. But I see that if I add this up, it's going to be more than 180. So I won't bother myself to add up. I'll just subtract the two values from 360. And that will be 360 minus 173 minus 75. And whatever you have becomes your angular difference. And in this case, our angular difference is 112. So this is 112 degrees. Hope you got that. If after you added this and this together, they are on different sides of the pole, the value you get, if it's less than 180, you use it. If it's exactly 180, you use it. But in this case, it's more than 180, you subtract from 360 to be able to get an angle shorter than 180 or less than 180. That's it. So the formula, they are both on a great circle. So we still retain the same formula, and that will be theta over 360. That's the A part of the question we are solving right now. Over 360 times 2 times 22 over 7 times 6400 we have already done theta, and we know that our theta is 112. 112. So when you put your calculator, you have something like 12516 kilometers. Then you can write your answer in two significant figures and write as 13, convert it 00 kilometers to 2 st. That's how to solve the first part. I will rub this off to solve the second part. Then you can pause it or rewind the video to go back if you need any more information. But let me rub this off and solve the second part. Now, the second part is asking us to set how far is Q from the South Pole. How far is Q from the South Pole? If you look at it very well, this my Q is on the equator. This is my South Pole. If you watched my previous video, I told you that the angle between the equator and the South Pole is 90 degrees. You can go back and look for my lesson on latitude and longitude, where I explained how to use the formulas and every other thing. So the angle here is 90 degrees. So this place is the part they are asking us. How far is Q from this? So they are looking for D. So this R, this one you're looking at here too, is also R. So this is the angle we are dealing with, that's 90. So my theta in this case is 90 degrees. My theta in this case is 90 degrees. I could change this symbol to something else, but I really want all the sign I'll be using in this tutorial to correspond with the symbols I've used in the previous video. That's why I'm not changing it. So, and go back, your Q, your theta I told us is 90 because this is on the equator, and the distance between here and here, the angular distance is 90 degrees. So I'll be using 90 here. So I'll just find the distance. And the distance here will now be this theta over 360 2 pi r. Why am I using the same formula? It's because, look at it. This is a longitude, and this point and this point are on the same longitude. And longitude is a great circle, so I'm going to use this formula. So we have 90 over 360 times 2 times 22 over 7 times 6400. And whatever you get will be your answer. In this case, you will get 10057 kilometers, and that will be 10,000 kilometers to two significant figures.
If you enjoyed our teaching, please click like and feel free to share our link with your friends, and do not forget to subscribe to our channel so that you can get notifications of our subsequent videos.